Linear and Nonlinear Functions, Lesson 14 Notes. Continuing types of nonlinear functions. The next type we're going to talk about are rational functions. Rational functions have breaks in the graphs. There are areas where the graph will not touch. All right. A long time ago, when you were learning about dividing, you learned that you can't divide by 0. Well, when you have a problem like this, there is a chance that the denominator could be a 0. And if that's the case, that's where we would have a break in the graph, because we can't divide by 0. So the denominator cannot equal 0. So to find where that is, I take the denominator, I set it equal to 0, and I solve. So the first thing I'm going to do is I'm going to divide both sides by 2. I get x squared minus 5 equals 0 divided by 2 would be 0. Add 5 to both sides. X squared equals 5. The opposite of squaring a number is the square root, so I take the square root of both sides. And if you remember, the square root of 5 would be an irrational number. The square root of 5 would be an irrational number. So in other words, x would equal positive negative square root of 5. It's going to give you a decimal that goes on forever. So if I go up here, this is what the square root of 5 would look like. Positive negative, or it's about 2.2360, and it keeps going. Well, if you look at this graph, I know it's blurry and it's hard to see, but here would be your 1, here's your 2. So this dotted line is at positive 2.2360 and so forth. So in other words, it's at positive square root of 5. And over here, here's negative 1, here's negative 2. So this dotted line is at negative square root of 5. Right? That is where we have breaks in the graph. We have breaks in the graph at those points. Therefore, this is called a rational function. You'll learn more about this when you get up to algebra and algebra 2. So here's another example over here. So those lines get really close, but they never actually touch. All right, so rational functions. So here are two examples, x cubed minus 2x over 2 times x squared minus 5. That's the one I just showed you. And then we've got 2x over x squared minus 1. So in that case, if x was positive 1 or negative 1, you would have a 0 on the bottom. So there would be a break at x is positive 1, and there'd be a break at x is negative 1. All right, do the best you can. It doesn't need to be perfect, but pause your video and get that drawn. Again, it doesn't need to be perfect. Just do your best. Okay. Next one we're going to talk about are root functions. So, if you're thinking about it, these functions are going to have roots in them. So here are root functions. So the red line is y equals the square root of x. The blue line is y equals the cube root of x. So we have root functions. They're going to contain a root. Now, I also put this picture on. If you look at y equals x squared, that would be a quadratic function. That is the u, the green line, the green graph. All right, and then the root function is this blue one. Now, the reason why that's the dotted line down below is because if we had this line down below, it wouldn't be a function. It would fail the vertical line test. Anyway, those are examples of root functions. So there are some examples, and there is a graph to draw. Pause your video, get all of that written down. Again, just do your best with the graphs. Okay, last one is an exponential function. Exponential function. Well, one year I had someone say, well, aren't there exponents in the other ones? Yeah, there are. If you look at the quadratic function, the highest exponent is a 2. For cubic, the highest exponent is 3. For quartic, the highest exponent is 4. But every exponent I just mentioned was a number. The base was the variable x, and the exponent was a number. Well, with exponential functions, the base will be a number, and the exponent is going to be your variable. All right, so if you look at these, there's a bunch of examples here. Notice how, I know it's hard to read again, but for every single one of these, the exponent is your variable term, and the bases are all numbers. Okay, so here's an example of y equals 1/2 raised to the x power, and y equals 2 raised to the x power. Notice they're going different directions. But look how both of these graphs go through the point 0, 1. Over here, all of these go through the point 0, 1. Why is that? Well, that's because the x would be 0. And except for 0, anything else raised to the 0 power is 1. 1 to the 0 power is 1. 5 to the 0 power is 1. 3,000 raised to the 0 power is 1. So if I had 3,000 to the exponent, so 3,000 to the x power, it would go through this point here in the middle at 0, 1. All right, so let's go back to the graph. I'm going to get this back up to the top. Go back to our video. All right, so some examples of exponential functions. Notice how every single one of them, the exponent is the variable. And here is a much simpler graph to draw for you. Okay, so these are just some types of nonlinear functions, all right? And again, please do not worry about, I'm not going to give you a test and say, give you a picture and be like, is this a rational function? Is this an exponential function? All I want you to be able to see is, are these linear or are these nonlinear? And if you looked at any one of these graphs, you should be able to say that they are nonlinear functions. You'll get to know more about these functions when you get up to Algebra 1 and Algebra 2. But right now, you just need to recognize that these are nonlinear functions. If you have any questions, please let me know.